Hi everyone, welcome to your own YouTube channel Infinite Iteration. So today I am going to start a new series which is basically going to be in English language. Prior to that I made a series playlist related to Python language, Python programming in Urdu or Hindi. If any one of you can read or write or speak or listen, Urdu or Hindi, you can check this. But today I'm going to start a new and fresh series that is going to be very important for you guys because it is very demanding course right now, and I see many top YouTubers even ignoring this course. So I made this course free for you. I made the slides and everything for you. So it is going to be an advanced operating system course. It is basically designed for masters and PhD level students, or even bachelor students can also do this, because I'm going to start this from the very basics and we will raise the bar like anything. Like we will cover all the advanced topics, all the emerging trends related to operating systems. Okay, so why study this course? Basically this course will be make you able, like if you want to publish an operating system in the market, you can use this course as a supplementary resource. You can use this course, you can learn from it, and you can design your own operating system. You will better understand the functioning of the OS, like we use Android, Mac, Linux, different operating systems, and you can better understand how they function in the backend, like behind the scenes. And we will cover all the advanced topics, all the emerging trends. Like today we have the trend of AIOS, artificial intelligence operating system. We will cover all of that, and we will cover from kernels, threads, virtualization, cloud computing, different clouds like GCP, Azure, AWS, and we will cover like containers, Dockers, Kubernetes, everything, you name it. I will cover each and everything related to advanced operating system, like OS security, vulnerability, and Android operating systems, everything. So let's start the course from the very basics. So I will first teach you the basics of operating systems, so it will build your foundation. So the first slide I'm going to show is the hardware. You must be shocked because operating system is a software, not an hardware. But why do I show this? Because hardware and software go in parallel, go together. So one cannot live without each other, without another. Okay, so hardware is basically a junk which cannot do anything by itself. Like you see on the screen, there's a hardware of something, motherboard or GPU or something, but it cannot function on its own. You need a software for it. So is it necessary to know about your machine hardware? Yes, of course, we should know about the specs of our hardware and everything in order to know what kind of functions it can be performed on our machine. So it is good to know about the hardware. So basically I'm going to show you a motherboard. It's basically shown like this. This is how a motherboard looks like. It's basically the very basic. I know all of you know how the motherboard looks like. You might be boring for you, but I'm just making this course for the beginners as well. I will start from the very basics and I will raise the bar like anything. Trust me, guys. So how to check the processor of your machine? Basically, here's an example of Intel Core i7 and 10065. Basically, is the 10th generation processor, G7. Okay, there are new chips available in the market right now. For Windows laptop, we basically have Intel and AMD, and for Mac, we know all that we have MacBook, Apple MacBook, and recently they are all making advanced chips related to AI. They call it that AI processors, and you can see the names on the screen. And another things we have is quantum processor, which works on the principle of qubits. Basically we have binary bits. The classical computer works on the binary bits, zeros and one, but quantum computer can simultaneously work on both at the same time due to superposition principle, and it can work faster and process parallel computation at the same time. So this is a brief introduction of quantum processor. Basically, a lot of research has been going on in this field, and it is an emerging field like quantum computing. So it is basically how a chipset looks like, and it basically acts as a central control system, and all the data transfer happens by the chipset. So I'm going to show you a chart, or you can say a diagram of types of computer memory. We have primary, secondary and cache. We will discuss all in future. Primary is RAM, ROM, and secondary optical disk, magnetic tapes, and further we have more classifications. So memories, as you can see, it's basically we are talking about primary memory. It's RAM, and the fastest one is DDR5 right now, and it was manufactured in 2019 and available in the market in 2019. And the earliest one was the previous one was DDR4, DDR3, DDR2, DDR1, all the way back to SDR. And you can see the voltage is decreasing, bandwidth is increasing, beginning speed like boot speed is decreasing. I mean, the processing speed is increasing. So we are going to talk about cache. Cache is basically a small type of memory located exactly on your core, CPU core. We have three different types of cache: L1, L2 and L3. L1 is the smallest and the fastest cache located directly on the CPU core. L2 is larger and slightly slower than L1, and it acts as a buffer between L1 and the rest of the system. L3 is the largest and the slowest of the three, and this cache is often shared between multiple CPU cores. So this is how our cache looks like. So the question is, do we need software? Yes, of course we need software. Computer is basically comprises of two things, hardware and software, and software is further divided into various subcategories like system software, application software, utility software, and we have operating system, language processor, device driver, BIOS, and application softwares we have general purpose application software, specific purpose application softwares, and the subcategory of language processor is assemblers, compilers and interpreter. So basically, what is a system software? System software is a type of computer program that is designed to run a computer's hardware and application programs. It is basically a layered model. It acts as an interface between the hardware and user application. As you can see, we have two different types of popular software: system software and application software. And if someone asks you what is an operating system, you will reply immediately that operating system is a type of system software, because it acts as an interface between the user and hardware of the computer system. So what is an operating system? Operating system is basically a system software which acts as an interface between user and hardware of the system. As you can see, user is lying on the top, and it basically we have application software like different applications where we see on our desktop of a Windows laptop or PC or anything, or MacBook even. And we have system software. System software is basically an OS, and OS is directly communicating to hardware. So another definition of operating system. So as you can see, we have two different types of devices here. One is a computer or laptop, and another one is smartphone, tablet, iPad, and it's the same thing. Operating system works as the same thing between the two. Like we have a user running applications is talking to operating system, and operating system communicates with the device driver, or in this case computer hardware directly. So what is a device driver? Device driver is basically like if you have a hardware device and you need to communicate with it, you need a device driver like a printer, mouse or keyboard. So device driver, like we can also communicate between different hardware devices like printers and personal computer communicate with each other. They are two different hardware devices, so we need device driver for it. And how to check your device driver? You can simply go to device manager and check your hardware device drivers. You can update it, modify it, disable it, uninstall it, and even scan for hardware changes and maybe further operation as well. So now I'm going to discuss about BIOS. BIOS is basically a firmware. It is a software which is first loaded into your, which is the first thing that is loaded when you turn on your computer. So BIOS is very important. So it initializes when you turn on your computer. It performs a post and then it detects the hardware. Then all the BIOS boot process happens and the interface is shown to you, and it also configure everything for you, for your startup, for your boot up. And we can also talk about CMOS, complementary metal oxide semiconductor. CMOS is basically a small chip, and it's like a coin shaped chip, or you can say cell, type of cell, and it basically stored all kind of configuration information, even date, time information of your PC, of your last boot up. If you change anything in your BIOS, it will be saved in CMOS. So BIOS initiates, CMOS provides settings, CMOS retains data, settings change in CMOS, and everything is like this. CMOS, as I told you, is basically kind of a battery on motherboard, and you can see in the image it's CMOS. And now let me show you about types of BIOS. Types of BIOS, basically we have two types of BIOS: legacy BIOS and UEFI BIOS. Legacy BIOS means that any bootloader can be operated on this type of BIOS, while UEFI only allows verified OS. They both are firmware and they act as a middleman between the software and the hardware of the computer. So UEFI basically called Unified Extensible Firmware Interface. It is a modern way of OS to load the program. As you can see, BIOS, as I told you, legacy BIOS, any OS loader, but modern boot like UEFI BIOS, verified OS loader only. One important difference: UEFI runs in 32-bit and 64-bit, while legacy runs in 16-bit only. And how to check your BIOS? You can simply press Windows plus R and type msinfo32 and press enter. Then this screen will show up to you, and you can check your BIOS, your computer BIOS. And let's talk about disk management. Basically, we are going to talk about two types of disk management. One is master boot record, and the other one is git partition table. Master boot record is an old way of partitioning the hard disk, and it basically limits your partitioning to 2 TB, 2 terabyte of space, while git is used for more than 2 terabyte of space. So as I told you how boot is loaded, first BIOS is loaded and it goes to master boot record. Master boot record is basically your disk management or disk partition, and in modern we have git partition, GPT, git partition table, and then it goes through active partition and then bootloader. So we have MBR and GPT. MBR is an old, as I told you, let's limit 2 TB, and for modern system like Windows 11 we have UEFI system with GPT, git partition table. So here's an activity, small activity for you. Like, you intend to buy a desktop machine and a mobile phone. Make a checklist of consideration for each system before buying. So try to pause this video and do it on your own self. It's just a small activity to make you able to brainstorm and how you are going to solve this problem. And so we are going to discuss about design of operating system. So basically, what comes to your mind when I say design of an operating system? So here are some of the things, like it should be efficient, it should be simple, it should be portable, it should be secure and protected, it should be scalable for future upgradation, and it should be reliable as well and robust. So like I told you, design objective is convenience, efficiency, and ability to evolve. So here's a small activity for you, like you in another activity, second activity of this course, of this lecture, sorry. So you intend to bring a new OS in market and you assume that it will get the corporate as well as mobile customer. So how you are going to design it? And this is a self test. You have to perform it and maybe make a notes of it. So what is a system software, what is an application software, what are the design objectives of an OS? It is already mentioned in previous slides of this video, or you can rewind this video or go back and you can check the answers and activities as well. Okay, thank you so much guys. This is the end of this video, of this very first video of this playlist. I hope you like it, and if you like it, please like it, subscribe it, comment my channel, on my channel. It will help me stay motivated and produce more and more content for you, because this is very high level content. It is not available everywhere. It is basically a master's level, graduate level content that I am providing you for free. So I just need your support in return. So please subscribe to my channel, like my video, comment on it, please. Thank you so much guys, and I'll see you next time.